Hello friends, welcome back to the channel PharmaChem Insights. UV visible spectroscopy is one of the simplest and most widely used analytical techniques. But what happens when your sample doesn't follow the rules? In today's video, we are going beyond Beer-Lambert's law. We will explore why deviation occurs, what factors affect absorbance. Whether you are a student, analyst, or working scientist, this will help you understand your data at a deeper level. So let's get started. First question, what are the components of UV visible spectrophotometer? So there are five components. First is light source, second is monochromator, third is sample holder, fourth is detector, fifth is recorder. You can see the diagram on the right hand side. What are the main limitations of Beer-Lambert's law? Beer-Lambert's law works only under ideal conditions. It fails when concentration is too high, light is not perfectly monochromatic, stray light, that is unwanted light, enters the detector, chemical equilibrium changes with concentration, instrumental limitation like non-linear detector response occur. Next question, what causes deviation from Beer-Lambert's law? There are three main types of deviations. First is chemical deviations. In this, association, dissociation, pH changes and complex formation occurs. Second is instrumental deviations. In this, stray light, bandwidth mismatch, detector saturation occurs. Third is physical deviations. In this, scattering due to particles or turbidity occurs. Next question, why do high analyte concentration causes non-linearity? So answer is, at high concentration molecules interact forming dimers, aggregates or complexes. This changes molar absorptivity and causes non-linearity. Next question, what is stray light and how does it affect absorbance? Stray light is unwanted radiation or light reaching the detector. It reduces absorbance, especially at high absorbance value, causing negative deviations from linearity. Next question, how does pH influence UV visible absorbance? The answer is, pH changes protonation states, which shifts the lambda max and changes absorptivity. Therefore, UV visible is sensitive to pH dependent equilibria. Next question, why is UV visible highly sensitive to turbidity? So answer is, suspended particles in samples scatter light, increasing apparent absorbance and violating Beer-Lambert's assumption of only absorption. This leads to false high absorbance readings. Next question, what happens when a sample absorbs too strongly? So answer is, detector saturation occurs when a sample absorbs too strongly. Absorbance greater than 2.0 absorption unit is unacceptable because less than 1% of light reaches detector. That amplifies the noise and stray light effects. Next question, how do you improve linearity in UV visible measurements? You can improve linearity in UV visible measurements by diluting high absorbance samples, by using proper slit width, by ensuring clean cuvettes is used, use monochromatic light, correct baseline background, avoid turbid samples, filter and centrifuge the samples if necessary. Next question, what is baseline drift and how to avoid it? So answer is, baseline drift is slow absorbance shift caused by first lamp instability, Second, temperature changes. Third, because of dirty cuvettes. Next question, why is UV visible not ideal for very low concentration? UV visible is not ideal for very low concentrations because at very low absorbance, that is less than zero point 0.1 absorption unit, noise dominates, baseline errors become significant, light intensity fluctuations affect accuracy. Next question, how does temperature affect UV visible absorbance? So answer is temperature changes solvent density, refractive index and equilibrium shifts, altering absorptivity and causing deviations from linearity. Next question, why should cuvettes be oriented consistently? So answer is small variations in wall thickness of cuvettes or optical imperfections changes the path length slightly. Consistent orientation of cuvettes ensures stable results. Next question, what is photobleaching in UV visible spectroscopy? So answer is photobleaching in UV visible is when some compounds degrade upon exposure to UV light, reducing absorbance with time. This leads to time dependent deviation from expected values. Next question, what is an isobestic point? An isobestic point is a wavelength where two interconverting species have equal molar absorptivity. It indicates a clean chemical equilibrium and no side reactions. Next question, what are the calibration parameters for UV visible spectrophotometer? So answer is the calibration parameters for UV visible spectrophotometer are: first is control of wavelength, second is control of absorbance, third is limit of stray light, and fourth last is resolution power. Thank you. I hope you liked the video. If you found it helpful, so please don't forget to like, share and subscribe my videos, and also show your support in the comment section. Thank you once again. Bye.